You think you understand distance. You don't. Right now, you're sitting on a rock hurtling through an ocean of light. Billions of stars surround you. You can see them, map them, measure them down to the atom. But here's the truth they don't tell you. You're already too late. Every single one of them exists in a past you can never reach. And the barrier keeping you from them isn't made of walls or darkness or even the void itself. It's made of time. And tonight, I'm going to show you why that barrier is absolute, why it will never break, and why the stars you're looking at right now are already gone. Let's start with the closest thing to us in the entire universe, the sun. It's only 150 million kilometers away. That sounds like a lot, but in cosmic terms, it's nothing. You could almost reach out and touch it. Almost. Except you can't because the light hitting your face right now didn't leave the sun a second ago. It left 8 minutes ago. You're not seeing the sun as it exists, you're seeing a memory, a ghost. Light traveling at 300,000 kilometers per second, and even at that incomprehensible speed, it still takes 8 full minutes to reach you. Now here's where it gets disturbing. If the sun vanished right now, just blinked out of existence, you wouldn't know. For 8 full minutes, you'd keep living. The sky would stay bright, birds would keep singing. You'd sip your coffee and scroll your phone, completely unaware that the star keeping you alive is already gone. You'd be living in a universe that no longer exists, trapped in the past, blind to the present, and there's nothing you could do about it. That's the nearest star, and you can't even experience it in real time. Voyager 1 launched in 1977. It's been flying for nearly 50 years, and right now, it's at the edge of our solar system. When it sends us a signal, that signal takes almost a full day to arrive. We're not talking to Voyager. We're talking to where Voyager was yesterday. Every command we send is already outdated by the time it gets there. Even here, in our own neighborhood, time has already separated us. And it only ggets worse. The Oort cloud marks the true edge of the sun's gravitational grip. It could extend out more than a light year. That means if something happened out there right now, you wouldn't know for over a year. A full year of your life would pass before the news even reached you. But that's still home. That's still close. Because beyond that edge, distance stops being measured in kilometers. It starts being measured in lifetimes. Proxima Centauri, the closest star to Earth after the Sun, 4.2 light years away. Let me make that distance visceral for you. In raw numbers, that's 40 trillion kilometers. If you got in a car and started driving at highway speed, you'd need 45 million years to get there. That's the entire evolutionary history of primates, from the first tree-dwelling ancestors to you, sitting here right now. That entire span of time wouldn't even be enough. NASA's Parker Solar Probe is the fastest thing humanity has ever built. It screams through space at 190 kilometers per second. At that speed, it would still take 7,000 years to reach Proxima Centauri. 7,000 years. That's longer than all of recorded human history. The pyramids, the Roman Empire, the Renaissance, the moon landing, everything we've ever written down, all of it would fit inside that journey, and you still wouldn't be there. Voyager 1 moves at 17 kilometers per second. At that crawl, the trip takes 73,000 years. Modern humans haven't even existed that long. And if you could somehow cheat physics and travel at the speed of light, which you can't because the universe won't allow it, it would still take 4.2 years. 4 years of your life moving at the absolute fastest speed possible just to reach the nearest star. But here's what breaks you. When you arrive, everyone you left behind is 4 years older. The world you departed is in the past. You can't go back to it. That Earth is gone. It aged, it changed. People died, people were born, politics shifted, technology advanced. The place you left doesn't exist anymore. It's been overwritten by time. Because traveling through space is traveling through time, and time only moves one direction. You'd step off your ship onto Proxima Centauri completely alone, not just physically, temporally. You'd be separated from everyone you ever knew by years you can never recover. And the journey between? Nothing. Absolutely nothing. No planets, no gas clouds, no cosmic landmarks, just void. 1/10 of an atom per cubic centimeter, emptier than any vacuum we can create on Earth. Darkness so total that if you stopped halfway between the Sun and Proxima Centauri, both stars would look like faint pinpricks of light. Cold, distant, unreachable. You'd be floating in a blackness that has no equivalent in human experience. Millions of kilometers from anything solid. Years of travel in every direction before you'd hit a star. This is interstellar space. This is what true isolation looks like. And this is the closest star. The stars you see scattered across the night sky, those are dozens to hundreds of light years away. When you look at the Big Dipper, you're seeing light that left those stars decades or even centuries ago. Some of them might already be dead, exploded into supernovas, collapsed into black holes, but their light is still traveling, still reaching your eyes, ghosts haunting the night sky. The Milky Way stretches 100,000 light years from edge to edge. Let me put that in perspective. Light leaves one side of the galaxy traveling at 300,000 kilometers per second. It crosses the distance from Earth to the Moon in just over 1 second, and it would still take 100,000 years to reach the other side. That journey would have started when early humans were still in Africa, before we had language, before we made art, before we even left the continent, and it still wouldn't have finished. 100,000 years is about 1,250 human lifetimes. If you lined up every generation from the start of that journey to now, you'd have 4,000 generations, 4,000 lifetimes, each person living, loving, struggling, dying, while a single photon crawled across the galaxy. At Voyager speed, crossing the Milky Way would take 1.7 billion years. When that journey started, Earth had nothing but single-celled life. No plants, no animals, no eyes to see the sky, just bacteria. Multicellular life wouldn't evolve for another billion years. Fish wouldn't appear for 1.2 billion years. Dinosaurs wouldn't walk for 1.5 billion years. And humans wouldn't exist for almost the entire duration. That's how long it takes to cross one galaxy. Just one. We're about 26,000 light years from the center of the Milky Way, from Sagittarius A star, the supermassive black hole at the galactic core. The light we see from the center left 26,000 years ago. Humans were living through the Ice Age. No cities, no farms, no writing. Just stone tools and fire and small groups huddled against the frozen dark. That light has been traveling ever since, across 26,000 light years, while human civilization rose and fell and rose again, while empires burned, while languages were born and forgotten. That light is older than the pyramids, older than writing, older than agriculture itself, and it's still considered local. The Milky Way contains somewhere between 200 and 400 billion stars, each one separated from its neighbors by light years. Hundreds of billions of suns, all isolated by time itself. We're trapped in our corner of the galaxy, not by distance, by time, by the cosmic speed limit that nothing can break. Everything you've just heard, the billions of years, the thousands of generations, all of it has been contained within this single island of stars. But if you thought the space between stars was the barrier, you're not ready for what comes next, because that was just the beginning. Let's leave the galaxy. Andromeda is 2.5 million light years away. The light you see from Andromeda tonight left when the first members of the genus Homo were just beginning to walk upright. Long before Homo sapiens, before refined tools, before fire was tamed, before we had words for anything. That light has been traveling for 2.5 million years, across a gulf so incomprehensibly vast it makes interstellar space look crowded. At Voyager speed, the journey would take 43 billion years, 3 times longer than the universe has existed.
You'd have to wait for the universe to be born, age, and die, then do it all over again twice just to make the trip. And the space between the Milky Way and Andromeda? It's emptier than your mind can process. If you could somehow suspend yourself exactly halfway between the two galaxies, you'd be 1.25 million light years from either one. Both galaxies would be faint smudges of light barely visible against the black. You could hold up your hand and each galaxy would fit behind your thumbnail. No stars, no planets, no structure. One atom per cubic meter. You'd be a million light years from the nearest star. A million years of light travel in any direction before you'd reach anything solid. No one within a million light years to hear you scream. You'd be more alone than any human has ever been. More alone than it's possible to be on Earth. Alone in a way that doesn't exist in our world. This is intergalactic space, the deepest isolation in the universe. And Andromeda is our nearest large neighbor. Beyond the local group, our small cluster of galaxies, the distances grow even more monstrous. Each galaxy separated by voids we can measure but never cross. The universe is full of places we can see but will never touch. But as we push further toward the absolute edge of what we can detect, we find the final version of the barrier. And it's worse than you think, because it's not just that the stars are far away, it's that the ground beneath them is moving. The observable universe is about 93 billion light years across. The universe itself is only 13.8 billion years old. How is that possible? Because space itself has been expanding since the Big Bang. The fabric of the universe is stretching, carrying galaxies away from each other faster and faster. TON 618 is one of the most massive black holes ever discovered. In today's expanding universe, it's about 18.2 billion light years away. But its light has been traveling for 10.8 billion years. That light started when the universe was young, when the first galaxies were still forming, when stars were igniting across the cosmos for the very first time. It traveled for 10.8 billion years, through expanding space, past billions of galaxies, until it finally reached the telescope on Earth. What is TON 618 doing right now, in this exact moment? We have absolutely no way of knowing. Light from TON 618's present day won't reach us for another 10.8 billion years. By then, the sun will be dead. It will have swelled into a red giant, consumed Mercury, Venus, maybe Earth. Then it will shed its outer layers and collapse into a white dwarf. Billions of years will have passed. Earth, if anything remains of it, will be a frozen cinder orbiting a dying ember. Humanity will be gone, either extinct or evolved beyond recognition. What separates us from TON 618 right now isn't distance. It's 10.8 billion years of unreachable present. And TON 618 isn't even at the edge. The farthest light we can see is the cosmic microwave background. It's 13.8 billion years old, the afterglow of the Big Bang itself, the very first light that could travel freely through space. It's been traveling since the beginning, from a time when there were no stars, no galaxies, no planets, just hot plasma cooling into existence. That light left when the universe was 380,000 years old, and that marks the edge of the observable universe. Not because the universe ends there, but because that's as far as light has had time to travel. Beyond that, the universe before light could move. Unknowable, unreachable. And here's the part that will haunt you. There are galaxies out there, right now, whose light will never reach Earth, because space itself is expanding faster than their light can cross it. Those galaxies exist, stars are forming, planets are orbiting, maybe life is thriving, but we will never see them, ever. Their light will never reach us. We're isolated by the structure of space-time itself. A light year is supposed to be a unit of distance, 9.46 trillion kilometers, the distance light travels in 1 year. But it's also a unit of time, a unit of separation, a measure of how trapped we are. When you look at something 10 light years away, you're experiencing two things at once. It's 94.6 trillion kilometers from you, and the light hitting your eyes left that object 10 years ago.
distance and time collapse into each other. They're the same thing. Humans evolved to understand distances we can walk, 100 meters, a kilometer, 10 kilometers. Those make sense to us. But a light year? If you tried to walk 1 light year at normal pace, it would take 214 million years, longer than dinosaurs have been extinct. Drive at highway speed? 10.8 million years, longer than the entire genus Homo has existed. Fly on the fastest spacecraft we've ever built? 1,576 years, 1 light year, and the nearest star is 4 of them away. People try to make cosmic distances comprehensible by scaling them down. If the sun were a grain of sand, Proxima Centauri would be another grain hundreds of kilometers away. The Milky Way would stretch millions of kilometers. But even scaled down, the numbers break your brain. There's no metaphor that makes a light year feel real, no comparison that works. The human brain isn't built for it. And that's the point. The universe operates on scales we're fundamentally incapable of grasping, distances measured in years of light travel, voids so vast that even at the cosmic speed limit, you'd spend lifetimes in darkness. We're small. The universe is vast, and the barrier between us and the stars isn't just distance, it's time. If you could somehow travel to another galaxy, you would arrive alone. Everyone you knew would be millions of years dead. The civilization you left would be ancient history or completely forgotten. The Earth you departed from would be unrecognizable. You could never go home, not to the place you left. That place would be gone, erased by time. This isn't science fiction, this is physics. Distance in space means separation in time, and time only moves forward. Every light year is a year you can never recover. Every journey is one way. The moment you leave, the place you left begins aging into something else. By the time you return, it's gone. This is why the stars are unreachable. Distance doesn't just measure space, it measures what you lose by crossing it. That's what a light year really means. Separation you can never undo. Time you can never get back. Moments you can never return to. And every photon that reaches your eye tonight has traveled across space and time to show you a universe that is already gone.